this one.
That's crazy.
The only way you can send an invite to somebody on that app is through texting. And so we wanted to play a 1v1 match after class one time. And so I had to get his number for that.
Okay, my dudes. Number 20. Yes.
Yeah.
22. No. 24. No. 26. No. 28. Singular. 30 is the 2 by 2 matrix. 2, -5 halves, -3, 4. Number 32 is singular. 34 is 3 by 3 matrix. -34, 29, 9, 7, -6, -2, -12, 10, 3. What questions do we have on those?
On 28, would you accept undefined as an answer rather than singular?
The instructions literally say write singular, so no, I would not. Although your answer is technically true.
Yes. That's all I had. That was pretty clear.
We do 20. I'm not sure that is wrong, but I don't know.
You just like say no.
I must have.
Or no, you don't.
It's supposed to be yes, but I must have found my third.
This was like easy, so it kind of did it all in my head.
24 minus 25. 24 minus 25. I know I did it wrong, never mind.
Okay,
What'd you do wrong?
arithmetic.
6 is in 25.
True statement. It's 24.
Exactly.
Okay,
And
Now the other one.
6.3, we did 12 through 20. That's what I was trying to say earlier. That's
sure. 12 through 20. Number 12 is -3, 3 1/3. Number 4, 2, 0. 16, 4, 0, 8. 18, -1, -3, 7. 20, 220 blueberry pies, 140 chocolate trifles, and 40 cherry cheesecakes.
A lot of stuff. Oh, well, something.
Yep, they must have had a largest class in their class reunion. What questions on those?
Pretty simple. What'd you get? Did you get 91?
Dang it,
You both got 91. You got 98.
You couldn't have followed the trend. You got a nice
You
one.
get another 91. You're all supposed to have
We
the same
did
grade.
the same stuff, but we both got 91.
What'd you miss?
1 and 2
I missed a lot.
drastically, and then barely missed 2 others.
1 and what?
1 and 2, I did entirely wrong.
It's pretty delicious. It's a nice one. All right, do we have any questions over the homework or the tests?
Nope, you killed it. That's a good question.
Because
Oh, I just used the technique of identities.
how?
On question 2, he magicked his way into it, and I didn't magic it at all. I did it in a very legal way. It was just a very stupid legal way.
It was the wrong way to do it, and yet you got it right. So I mean, I guess because
You legally
that's just
can run down the street.
You can get to the mall down Slide, or you could go down University. What? Both will get you there eventually.
True facts.
we do number 1.
On the test?
Yeah.
Sure.
Number 1. Number 1.
Should we do it the traditional way or the
Oh,
correct way?
number not of
You might wanna pull these out. so you
I
can
heard.
read.
Oh, yeah, I forgot. I
Number
heard.
one. Number what? Number one. What? What? We didn't do number one. Number one?
No, I heard number one. I was just confused why you said number one. Like,
Yeah, because we did 12 through 20. I want number one.
on the test, or?
12 through 20 was homework. So I want number one.
Yeah. Let me do number 20 on the test.
Yeah, because the test definitely extended to number 20.
Oh, my way was so much better doing this. It was so fun. Not really wasn't. It definitely was not, but it was. It was the longer way and the way that made you have to stay another day. You were probably gonna stay another day anyway. I was gonna stay another day.
Okay. What should we do?
Oh, snap.
Now what?
How did y'all do it?
Oh, wow. Look, comments.
Oh, we should make a triangle.
We should make a triangle on a coordinate grid. I agree.
What are you
Hi.
teaching? Hello?
Sorry.
Our hearing?
Questions on a test over trig stuff, and then we're doing matrices, solving systems after that. All right. Yeah. This guy.
He's a fun little guy. Figure out where.
Where is cosine positive?
First and fourth.
First, yeah, right side.
First and fourth. So either here, first and fourth.
Yeah, bottom right.
Oh yeah, that's true. Yeah, that's true. That's true. We're doing number one, right? What are we doing?
Tangent's also
Tangent's also positive, so it has to be one.
So it's got to be one, not these one. It's this one, right?
Yeah.
Great.
And then
Now what? What do I put where?
opposite hypotenuse. So
On the right.
3 right there. 1 right there.
yes. 3
Great.
squared plus 1 squared equals 4, and then square root of 4 is.
1 plus 9.
Oh yeah, you're right.
Of course, I have
4 definitely doesn't work.
Why that was weird. Yeah, square root of 10. Square root of 10.
10.
Everyone is all off, Landon.
And then
Square root of 10. Great. What is secant?
I cannot understand, he says. Secant equals.
You cannot understand. You cannot hear me, or you cannot understand. Let me make sure the audio is working. That'd be a good thing to check.
Square root of 10 over here. Secant is the thingy.
Working. Yes, audio is working fine.
1 over the thing.
Square root of 10 over 10. It's square root of 10 over 10.
You got to ask a better question than I cannot understand, and then maybe I can help you. All right. What is secant?
Square root of 10 over 10.
That isn't really what secant is, but
1 over cosine.
secant is hypotenuse over adjacent, right? 1 over cosine.
Oh, yeah.
So how about square root of 10?
Oh, I did it wrong. Because the 10 and the 10 cancel.
You should have just done it. Cosine is square root of 10. You should come to the dark side with me, Reese, and do it with Pythagorean identities and just have fun.
You could do Pythagorean identities for some strange reason. It's working. DW.
What did you find?
Okay.
DW.
What about cosine? Cosine is going to be square root of 10 over 10, right?
Yes.
Right. Any other questions from this test?
No, I understand. I don't know what I got wrong. Now I understand. I just did everything I got wrong with question 8.
Question 8. You don't know what you got wrong.
I got -2. You put 2 question marks. Like maybe you.
And I got
-2 as well. Yeah, maybe you didn't even know what
I
I
only
got.
got -1.
You should have 4 answers on number 8.
I left off 2.
Because when you factor it, you end up with we end up with cosine x equals 0 and cosine x equals 1.
Yeah,
I got that.
And so then you need all the answers for all of those things.
I did that. I did 0 plus 2n pi and pi over 2 plus n pi. Yeah.
Yeah, that's half of them. Oh, you did n?
I did.
Oh, I must have missed that.
I did.
Ask me after and I can do it. Did you, let's say, did you do the correct ones though? Because you may have, I feel like I remember you having it, somebody having it, you getting the idea, but it bouncing like between 2 instead of all 4.
I did.
So make sure what the plus n's that you did will actually hit all four quadrants,
I did.
or all four axes.
Is
But
pi over 2 plus 2 in pi and pi plus 2 in pi? Right?
Pi over 2
plus n pi and 0. Yeah, 0.
this is from a test, so we're going over that. Don't worry, we'll get to something that's more helpful to you in a minute, sir. Any other questions from the test?
I just totally forgot to put those in my answer.
Pi over 2 plus 2 in pi and then pi plus 2.
Okay. Let's look at the. Were there any questions over the homework? See or no?
No.
Nah.
Okay.
It was simple review stuff.
Simple review stuff.
Let me get my notebooks out.
Kramer's rule, inverses. See, did we hit all the stuff in this lesson?
I like
Yeah,
Kramer.
we did.
Both in sine and in his rule.
Wow, that was totally and completely and utterly unnecessary. I didn't appreciate it.
I was really
All right.
like whiplash.
Can we vote to take mathematics last time?
Let's move on to 6-4. Partial fractions.
I like that.
On the board, no. I don't know why you're saying no. I'm sorry. You seem to be demanding things of me, and I don't know if I appreciate that. Okay.
Hello, sir. No. Sean's going to get bullied by some. Hello, sir. How do you
No, you only get bullied if you allow yourself to get bullied. We're going to learn partial fractions. Starting by learning partial fraction decomposition. Sound good? Yes. This is another one of those topics that is particular. Are you good? Well, don't worry, you'll be able to see me again soon. Okay. Where was I? This particular topic is one of those topics that is particularly useful as a pre-cal topic, right? Some of pre-cal, we've talked about this before. Pre-cal kind of hits three things, which is why I think like Saxon calls it advanced math instead of calling it, is my video frozen? Because I'm still not on the screen. Let me see. Let's see whether my video is frozen.
The camera's being happy. Showing things that are good. Malcolm literally sitting on the table looking at it was kind of
Except
wild.
he was like,
Oh yeah, my camera is frozen. Give me a second, bros. It's probably because Malcolm bumped it.
Boo. Malcolm, you suck.
Okay.
beat him.
All right, there you go, people. Malcolm, hands off. Okay, anyway, where were we? Partial fractions. This particular topic is very useful for like calculus 2. When we start doing methods of integration, and we have to do integration with partial fractions, which is a gigantic pain in the keister, but it'll be easier if we do this. This is 6-4, partial fractions. All right, we're going to start with an example. Let's do this one. What are y'all whining about? What are y'all doing?
So I was telling him what page in Spanish.
Okay. Doesn't seem very useful, but whatever.
It's extremely useful.
Yeah, it definitely is. You gotta know what 398 is in Spanish.
X minus 20. All right. So we are going to write the partial fraction decomposition of this thing. We're going to have to use some things that are just normal polynomial algebra things that we've seen before. Can move the cam to the student. I want to see. Nope, sorry, can't do that. They are silly, but nope, not going to do it. If they want to put their face on the camera later, they can do that on their own time. All right, so the first thing we need to do simply is we need to factor the denominator. Easy peasy.
That's a 13, right?
What?
That's 13 up there, right?
It is a 13.
Oh,
So
wait.
we get
What?
x minus
It's supposed to be an 11. Wait, never mind.
5
Maybe.
times x.
What are you crying about?
Oh, I thought you were like doing one of the examples in the book, but you're definitely not.
Definitely not.
So I wrote
Okay. x and x, and then what?
Negative 5 and positive 4.
5 and 4. And it's got to be negative 5 and positive 4 because the negative x in the middle. Easy peasy, right? So far, so bueno. Making sense so far?
Yes.
So, what we need to do is we need to decompose this. Okay? So, now we got it factored, we got something useful. We're going to say this equals a over x plus 4 plus b over x minus 5. Don't beg. It's unbecoming.
Is he begging to see
Yeah.
our faces or
Yeah.
something?
Okay. Anyway, making sense so far? How we doing? We doing good?
Where did the A and the B come from?
They're terms that we've got to
Out of my butt. They are things, they are going to be expressions or numbers that we need to find the answer to. Okay, chat, you're distracting my students in class. So focus. So either get on the page, on the same page and add something useful, or I'm gonna boot you out of here. Okay, how we doing? We doing okay so far?
So we've got to do some division.
So we gotta do a system is what we gotta do. Is what we gotta do.
Are we trying to figure out what A and B is?
We gotta tell you what A and B is. Well, let me rewrite this. Actually, let me just erase the green bit because the green bit is how we got these bits. Are we good, guys? Do we need to like remove the caps? I don't know. Are you sure? Because I'm not sure if you're focused.
We know where the A and the B are.
Okay,
because
so-
of the composition of X.
No, this and this, not the A and the B. The A and the B are the things that we pulled out of our butt, right?
Yeah, I know.
Okay, good.
We got that.
Okay, got that. Now, if we want to take this and we want to turn this into something that doesn't have fractions in it, how do we do that?
Multiply both sides by x squared minus x minus 20.
Yeah, which is like these two,
Yeah,
right?
but-
Right. True enough. True enough.
A times X plus 4. Wait, no. That's not how that math works. Never mind. Why are you like singing there?
X plus 4 times x minus 5, right?
And then we
So when we do it on the left side, what's going to happen?
It's going to cancel.
It's going to all cancel. So what's going to be left on the left side?
X plus 13.
X plus 13. Easy peasy, right?
Yippee.
And it's always going to be like that on these. You can actually kind of go straight from this down to here without even write that down if you need to. But no. Now there's a big mistake there. It wouldn't be just A plus B.
It's A times x minus 5.
Yes.
Plus B times x minus 4.
Yes. On the A term, the x plus 4 cancels, right? So it would equal, excuse me, A times x minus 5 plus, then B on this one, the x plus 4s cancel, right? X plus 4s. Making sense so far?
Yes.
We have something now that we can write some equations from. What equations? What equations indeed?
Oh, we can make some weird looking systems.
We can make some weird looking systems. What can we do with this first little chunk here? We can distribute the A.
AX minus 5A.
So
True enough.
1 minus 5, which would be the system part, which would be 4, right? No, negative 4.
We can distribute the B over here, right?
We're just distributing right now.
I'm just distributing right now.
Okay, so we get AX.
We'll see why in a minute. It's all going to crystallize into a nice picture. We're just kind of doing some math. Don't worry, it's going to gel into a why we've done these things. Oh, we've got AX minus 5A plus BX plus 4B equals all this.
Yeah. Oh, wait.
So what could we do now?
We have like terms?
We are going to have that's exactly what you're thinking. Like terms is correct way of thinking. We have some like terms here, but we don't really want those because there's not any A's and B's over here. So we need like terms that match this junk, right? So we could use the commutative property to rearrange these terms, right? We just got to keep our SIGN straight, right? So we could take and move the x's together and the no x's together. So we could turn this into AX plus BX minus 5A plus 4B.
That was easy.
That was so easy. It was just like milk toast. No big deal.
What?
I don't know what that means.
Now,
Milk toast.
yeah, so easy. As easy as milk toast.
What does that even mean?
Okay.
It's going to be okay.
I'm just gonna accept it.
We need
Good.
to move on.
Accept it and move on. Okay, so what else could we do here? What else could happen?
I don't know.
A, B.
What if on the first one we factored an x out? Yeah, and so I'm going to write it different than the way we normally do it. Normally we factor out the x and we put the x in front and the other thing on the second. But I'm gonna do the what's left first, and I'm gonna do it that way for a reason.
What do we do for the second one? Do we do like, I don't know.
I'm gonna add a little bit of a thing here, just to further clarify.
Things scare me.
Oh, so it looks like we factored, but we didn't actually change it.
Yeah, we didn't change anything. We didn't pull anything out, but I put it in and I did square brackets because I don't know. I just did square brackets. Same as round. Why is what? The sign didn't change. It's a great question, and I'm glad you caught that. So why did the sign change? The sign didn't change. Look again. Did the sign change or did it not change?
Oh, we just
I just made this a plus.
Yeah, you just put the thing.
And the minus is still there, right? And the plus is still there. We multiply 1 times everything, it's just itself, right? So I just grouped it, is all I really did. And I made it a plus. And I made it a plus because that's a plus.
Oh.
I like pluses.
What could we do now?
Add things, or sort of, yeah.
Wait, do you want a 0 on one side? Or
No, that's a good thought. We don't care about getting zeros. We're not doing polynomials.
Are we doing
So-
something with x plus 13?
We're about to.
Okay.
I'm going to go ahead and bring him down.
What an exciting young man.
X plus 13.
Yep. He's 13
Right.
years old.
Well, we don't know what the X is. So
We don't know what x is, and we're not going to know. We don't care what x is.
Oh,
So this is in the same format as this.
So do we know that A times X plus B times X equals X?
No.
Okay.
We know that a plus b equals 1 because they're in the same place.
Oh.
We know that negative 5a plus 4b equals 13.
So I was thinking that, but it
That's
didn't,
so
like,
easy.
it didn't make sense in my head. 'cause
I didn't
feel
know
like,
if we could just assume that though.
yeah,
I guess so.
Equals 1. And negative 5a
It's so nice.
plus 4b equals 13. Now we got a system. 2 variables, 2 equations. We can solve that. Easy peasy lemon squeezy.
What?
So what method you want?
one of them.
We should like do substitution.
Yeah, I like substitution best. It's my
I think
favorite.
that's a dumb idea, but sure, why not?
No, wait. We should do Kramer's rule. Yeah.
Kramer's rule sounds great. Let's do Kramer's rule. So the coefficient determinant, we got all the coefficients, 1, 1, negative 5, 4. The A determinant, we swap these with the A ones, so put 1 and then 13 and then 1 and then 4. And then the B determinant, I'm not really giving myself good space. I guess I'll write it to the side. The B determinant, we swap the B coefficients with the result ones, 1 and then 13, and then this is still 1 and negative 5.
Yippee skippy.
To do the determinant, what do we do?
1 times 4 minus.
1 times 4 minus the up diagonals, negative 5. So ka-chink, ka-chink equals 9. don't know what that says. I can't read from here. Maybe I'll look at it in a minute. And then this one, down diagonal, 4 minus the up diagonal, so 13.
4 minus 13 gives us
Negative 9.
high all.
Oh, high all. High, is that a strawberry or is it just orange?
It's just orange.
Okay, great.
Half.
Hi, whoever your name is. All right, one time, and then we do the down diagonal, so 13 minus the up diagonal, so minus negative 5. We ka-chink, ka-chink. 13 plus 5, 18.
Those are all good numbers.
So A
They all like good.
is negative 9 divided by 9,
Is negative 1.
negative 1. And B is 18 divided by 9, which is 2. So the partial fraction decomposition of this is negative 1 over x plus 4 plus 2 over x minus 5. How we do it?
Do we end it like that?
We end it like that.
That is a crazy looking answer.
And you could work this out, doing all the math that you know algebra know how to do to turn this back into this to prove that it works, right?
Find the partial fraction
Okay.
decomposition of each fraction.
So I guess I just didn't understand the goal from the start.
The goal was to find the partial fraction decomposition, which is this.
The goal was to find A and B.
Yeah.
Except then put it back over the.
Yes.
So if we were.
This is, and that, so the definition of the partial fraction decomposition of this is split into fractions. So you're doing the opposite. You know, normally if we have multiple fractions, we put it into one fraction. You're doing the opposite of that. So you're pulling it into multiple fractions. Does that make sense?
A lot of guessing, but you wouldn't actually need any of the work. Wow.
Okay. So
Don't do it.
Whatever you're trying to do, I'm just telling you don't do it.
I'm not gonna do it, but it's what I first thought we would be doing.
you have an idea for another crazy method? Is that what you're
you
mumbling
guess
about?
and check until you're fine. It's on the top.
You could totally just start throwing random numbers in there and YOLO and hope for the best. I don't recommend that. But yeah, I mean,
Doing it first, like with a structured way, you go.
I mean that can work. Let's do something else. So in this case, the degree and the numerator and the degree of the denominator, how do they compare?
It's 1 on top and 2 on bottom.
That is what they are. How do they compare?
Bottom is twice the top.
Bottom is twice the top. It's also just bigger than the top, right?
Bottom is bigger than the top.
Bottom is bigger than the top, yeah.
But what if the top was bigger than the bottom?
Or if they're the same, let's take a look at an example with some things like
The
that.
top is the same as the bottom.
That's not what you said, Vito.
What if you?
What if you say?
What? All right.
I said, what if you just?
Oh my gosh. Y'all quit misbehaving. Quit acting like fools.
We're just doing sign language.
You're just doing sign language.
Sign language.
All right.
Not American language.
Let's find the partial fraction decomposition of 2x squared plus 5x minus 4 over x squared minus x. What do you think we're going to do? Now, right now we've got these are the numerator and the denominator. They have the same degree.
I think you factor both of them in.
That's a great thought, but no, that's not what we're going to do. It's not going to be quite that simple.
Factor the.
No, wait, what if we just factor the bottom? I like
What if we divide it?
divide by
So multiply by x squared
or minus.
minus x over. I don't like reciprocals, but they work.
They like cancel everything out, so I can't. Oh, we're.
There's no equals. You can't do all that. Not whatever y'all are saying. That'd be illegal.
Actually, do this thing. I forgot about this.
Synthetic division. Oh, I hate this.
We can't do synthetic because this one's
Sorry, yeah, not what the.
just regular long division.
I totally forgot about this.
So we couldn't just like multiply both sides by reciprocal, or multiply by reciprocal because there's not both
I
sides.
thought you said.
That's true. Yes. everything you just said is correct. We can't multiply both sides by a reciprocal because there's not sides. There's not even sides. All right, so what do we do?
We put a 2 on the top.
Is it supposed to be? Yes, right there.
And, like,
It
put
is supposed to be a
two on
plus.
the top and do some multiplication.
We do put a 2 on the top. Why do we put a 2 on the top?
Because x squared goes into 2x squared twice.
2x squared divided by x squared is 2, which is what you said, but non-backwards. Okay, now what do we do?
Now we multiply 2 times 2x times x.
The simple word you're looking for is distribute.
Let's go with that word.
2 times x squared is 2x squared.
Minus.
2 times negative x is negative 2x. Now what?
Now we can subtract the negative.
Yeah, we subtract, which is what you meant. This cancels, because of course it does.
7x.
7x, true.
I know math, guys.
And now we have a 7x minus 4 as a remainder.
Now we have 7x minus 4 as a remainder. That is true. That is.
7x minus 4. 2.
Plus 7x minus 7x
So,
minus 4.
Wait,
this.
I forgot how to write a remainder.
Oh, that's well. It is important that we know how to write a remainder.
That was a long time ago.
It is. It's exactly what you said. The remainder would be this over this. So this is the same as 2 plus 7x minus 4 over x squared minus x. So what do you think we do now?
Now we split that one up.
Now we do partial fraction decomposition of that guy, because now we can do that. That is exactly right. That's totally, absolutely correct. So now that we know how to do partial deconstruction, what are we going to do?
So what are we going to do because there's a 2 that's not involved?
He's gonna, in the answer, in fact, well, let's so we can take the 2 off and we can remember he exists. The answer is going to be 2 plus all the other stuff. Okay? So, what do we do with this?
We get x plus 0.
No. Not x plus 0.
Minus 1.
A over x
X plus 0.
plus b over x minus 1, right? That would be the factored version of this. Is that what that's what would happen, right? We following good?
X plus 0. Let's go.
No. It is x plus 0. If that makes you happy, then yeah, I mean, that's not technically
I
wrong.
thought you were going to write out the parentheses, and so that's why I said x.
Even if I'd written out the parentheses, it still wouldn't be x minus 0. It'd just be x. It's just a GCF.
You know, anything plus 0 would work.
Okay. Anyway, as we were saying, what now?
Now we find we multiply.
Yeah, we multiply. So on the left side, whoosh, it all cancels. So we've got 7x minus 4 equals, and then
X minus
a times x minus 1, b times x.
bx. Plus b to the 0. B times
Plus b times 0. Yeah, that's true. We could put whatever you want times 0 at the end, and that's true. What now?
Now we distribute.
Distribute the a, right? That's true. 7x minus 4 equals ax minus a plus bx
Plus b times 0.
plus b times 0. Now what?
Now we rearrange.
Now we rearrange. Go ahead and pull an x out, right? So a plus b x minus a.
So then a equals negative. A equals 4.
A does equal 4. Yeah. That's absolutely true.
And then we know
That's which is a little bit tricksy SIG in. That's tricksy sign, right? But negative 4 equals a, so a just equals 4,
yes.
right?
So that means b equals
Or you could say negative a equals negative 4 if you were feeling especially spicy, but right.
Which Reese apparently is today.
So a plus b equals 7, and A equals 4. Now we should definitely use substitution.
We should definitely like just
Because
say
A
B
equals
equals 3
4.
through
4
magic.
plus
B
4
equals
equals
3.
4 equals 7 minus 4. 4 plus
So the partial decomposition would be
7 minus
2 plus 4 over x
plus.
plus 3 over x minus 1.
Yippee skippy!
Did you say over 0? Because you just broke
4
it.
over x plus 0 plus 3 over x minus 1.
Easy peasy. How we doing? How we doing on time? Pretty good, actually. Doing good today. Trucking right along. Let's do an even scarier one. How about?
Hopefully not. I like the non-scary ones where we can just like automatically know the answer because A equals 4.
Because A equals 4.
That one guy said sorry from earlier.
Yeah, I know. I saw that.
He said sorry.
We accept your apology,
If
weirdo.
you're still watching,
I don't know why you want your faces.
Boys, y'all are going to break something. Stop it. You're around expensive equipment.
Okay.
come on Malcolm, don't touch anything.
Hey, it was Malcolm's toilet. I'm gonna sue him for damages.
For harassment.
Now I can sue him for theft of property.
Okay.
So
Yeah, let's do a decidedly scarier one.
that's fluffy.
All right.
Not very.
Approximately that fluffy.
X squared
I don't want to put that on.
Yeah, you do.
No.
Don't you like
minus 3
birds?
We gotta write stuff down, guys.
x
Walk
He
in.
hasn't even finished writing down the original
Lock
thing.
in.
minus
Lock in.
8 over x cubed plus 4x squared
Aw.
Too bad.
plus 4x. Now find the partial fraction decomposition of that.
Yay, division.
So
Yippee.
what do you know?
No, we can't because 3 is bigger than 2.
Because 3 is bigger than 2, not division. Not at all division.
Triple factor? Pull an x out of everything?
We are going to have 3 fractions. That is true. We may want to, just for our sanity, go ahead and write the factored version over here because it's a little bit crazy, right? Squared plus 4x plus 4. Oh, that's now easy, right?
X.
But it throws a wrinkle.
Is it plus or minus?
It's not plus or minus.
Plus. What is the root?
2 plus 2 is
There's 2 of them. That's the wrinkle. So, when we're writing all the, what?
Can you just ignore one?
No, we can't just ignore one.
Hey, that's my.
We can't do it.
I ignored that one. That part of it. That part of it is important.
That's the redheaded stepchild.
That's crazy, Bert. I don't get it. That might be a good thing.
I don't know how you don't get it, but
Yeah, that's kind of odd that you would do that.
Sean says.
All right, what happened?
You just. Ooh, what did you do?
What did I didn't do anything particularly complicated.
So why though?
Yeah, why is life on here?
Okay, because there's 2 of them.
So you can't just put both out there. You have to put one in squared.
You do. We got to list it by itself and the squared version.
That's annoying.
That's strange.
Oh no.
So if it was like not the same, like if it was x plus 2 and x minus 7 or whatever.
Then it just be listed individually.
Okay.
You only have to do this if there's multiplicity. So if you have multiplicity, you have to have all the variances of it.
I can't be fluffy hair guy.
So, negative x squared minus 3x minus 8 equals a times what?
8 times x plus 2 cubed.
Not cubed. Yes, cubed. Yes, cubed.
Because it's,
You're correct. No, you're not. You're not right.
Why am I not right?
Because it wouldn't need, the squared includes the to the first.
Oh, it does?
Yeah.
Oh, that's nice.
Yeah, I mean, that's just math, right?
Well, I didn't know we could just ignore one now, though.
Well, that's so. Let me. You're not really ignoring one. It's let me kind of go way back. So if I have like 2/27ths plus 4/3 plus 2/9. We don't have to multiply this one times 9 because there's another 9 and whatever else it is, or this one times. You only have to multiply this one times one of the 3's. This one you'd have to multiply times 3 and then times 3 because it's missing both of the other 3's. But this one you only have to multiply times one of the 3's. That's exactly right. Yeah, least, not greatest.
Yeah.
Greatest is we just keep on going. Yeah, I know.
No, if you put 1 at that first one, it would have worked for would have lined up with that equation.
I don't know what you're saying. Okay.
If you put 1 a over 1.
Okay, so back to where we were. So it's going to be x plus 2 squared. Now we could, since we know binomial squared theorem, we could go ahead and do that, right? And go ahead and put the actual squared version. So what would the squared version be?
X squared plus 4x plus 4.
4x plus 4. True enough. Which we also kind of already have over here, right? So any way you want to get to that, it's going to be the whole schmagoigle, right? Excuse me. Plus, what's going to be the next one? B.
X plus 2
Well, you're missing something.
Times x.
Times x. Bx times x plus 2. And then the last one is going to be what?
C times x.
C times x plus cx.
That's simple, the last one.
It is simple on the last one. It's funny because when you first learned about letters in math, you're like, oh no, that's complicated. And now you're like, oh, CX, that's no big deal. Whatever.
It's just CX.
Exactly. So now what?
Now we have had to deal with half words for a whole unit.
Half, yeah, that's true.
cost
Okay, what now?
ax squared.
I didn't say what we get. What do we do? Distribute. Yeah,
Yes.
true enough.
ax squared plus a4x plus a4.
4a.
Okay, so ax squared plus 4ax plus 4a plus bx squared plus 2bx plus cx. Okay, so now we need to group things. How are we going to group them?
By the squared and then by the x.
We need to just like make them go.
By the x squared, by the x, and then by the no x. So we've got these guys, and then we've got these guys, and then this one is all by his lonesome.
Oh, what is that little way? ax squared plus bx squared plus
So equals
ax plus 2bx.
a plus b
Times
x squared, right? Those are the ones that have got the x squared.
Yes.
a plus c
Plus a plus b plus c times x.
Oh yeah, a plus 2b.
a plus 2.
Oh yeah, you're right. My bad. I made a mistake. Thank you. Good catch. 2b. And then plus the 4a.
Bro is just like forgot about that underneath that.
Rudy forgot to bring his
X squared minus 3x minus 8. So now it's system time, right? Luckily, and this will often be the case on these, the system isn't that bad.
-1. A plus b equals -1.
A plus b equals -1. True enough.
Plus 2b plus c equals -3.
A plus 2b plus c does equal -3 right there.
And a
And
equals -2.
it does, but just for the sake of clarity, 4a equals -8, which is very simple. But since it's not just like it equals this number, I went ahead and wrote it down, right? So we don't make mistakes.
For a second I was like, where did we get those things? Then I was like, oh yeah, left.
Oh, yeah.
Kind of like on the left side.
Divided by 4. So A equals -2.
And B equals 1.
Plug in a -2 up here.
A plus -2 equals -1, which means plus 2, and then you get 1.
So B equals
Uno.
1.
I don't know how you say negative in Spanish.
And we got a lot of mess. I'm going to go ahead and plug it in. You might could try to do it in your head, but I would not. So -2 plus 2 plus C equals -3.
And we like kill the first
And we kill the first part.
-3.
C equals -3.
And now we need to put things there.
So the partial fraction decomposition would be
-2 over x
-2 over x
1 over x
plus 1
2
over x plus.
-3 over x plus 2 squared. Now put you on.
I went in it late.
You kind of sold.
Maybe he's the cult leader. Okay.
Nah, he's the
Nicole
I'm the stock out.
Either we made a mistake or they did because they have +3. Oh no, just kidding. Let's see. Did we make a mistake, or did they make a mistake?
I let him.
Probably them. Did I copy the problem down right? Yes, it was. All of that would be positive. So yeah, I think they made a mistake. I would, as far as neatness.
I'm looking. Yeah, B is, A is
that
done.
way. Check the chat box.
Hi, sir. What are you teaching? We're doing partial decomposition of rational expressions.
Yippee.
This is high school pre-calculus.
Yeah, you should just respond with pre-cal. No extra context.
For neatness, what I would do is I would put this negative over here.
And then say, we got a fluffy haired kid, and then 2 other
But
us.
either way, it's technically fine and correct. Okay. Homework. Ooh, wow.
Does that mean we get to go home? Or does that mean
What is today? Tuesday? Oh yeah, we're about to take a test.
Thursday. Already?
Not Thursday. Tuesday.
Okay.
Yeah. Cool beans. Indeed.
Guess quick, boys. We gotta guess quick. Page 402, 2 through 18 evens. No, that's not.
We're going all the way.
Oh no, I
2
through
through
54.
30, no, 40, 43 at least.
43, we do evens, stupid.
Well, I know, that's just the section. Hold on.
402
34.
numbers
54.
2 through.
Please don't do 54. Please no. Please no. 38. 38. Or 34. I'm actually more happy with 34.
It's 38 or 34. I'm pretty sure it's 34.
32. Even.
Yeah, even better.
I was closest, guy.
So, because we're running up against a test and we're running up against we're done with this unit, I'm actually gonna, for the first time in a long time, let you go early.
Yay.
I am currently at 11th grade, but I've completed almost everything but not calculus, and here I am still. Well, welcome, sir. Glad you joined us. You're welcome anytime. Our classes meet on Tuesdays, meet in person on Tuesdays and Thursdays every week at this time.
Maybe you can see us well before he turns off the camera.
Oh shoot, they can see us.
Well, yeah, if you walk around, they can, but I'm about to stop the stream, so.
Oh no, run boys.
You got
Quick, go!
I don't think the guy that wanted to see your face is even here anymore, but.
I would be kind of concerned about
My
that.
stuff's falling off from the camera.
Truthfully.